This is the topic 5 cycle 1 homework video. We're getting into basic circuits. So here's a picture of one of the circuits from today's lab. And notice the light bulb is on, which means we have a closed circuit, or that switch is closed. That allows electricity to flow. Now if we started and we wanted to trace the path of electricity, then we would trace the direction that a positive charge would flow, which would mean from positive terminal, around, through the light bulb, and back around to the battery. Now on our simulation, we noticed that we set up this same setup, except for we made the battery one battery with 3 volts, since they're each 1.5 volts. And then we could see the voltage drop. So for example, these 3 volts, on one side we have 3 volts of energy, the battery uses those, and 0 on the other. So we had to set up a voltmeter on either side. So there's 2 probes on the voltmeter, one on either side of that bulb to see how much energy it uses. We wanted to see how to use the amp meter, the multimeter with the amp. We had to break the circuit. So if we did that with the real one, which we will be doing in our next lab, you'd open this circuit and then put one probe here and one probe here on the switch to make current go through the meter so you could measure how much current's flowing. Current flowed because we had a power source that created an electric potential energy across it. Battery using chemical energy in there. We had a resistor. So a light bulb is a type of resistor. There could be a motor, there could be something that just dissipates it as thermal energy, something that's using the energy. If we didn't set up a resistor there, then we'll talk about what happens with the current. You could also have a switch, which we included, to turn it on and off. Now, when the switch is down or closed here, that lights the circuit, that closes the circuit. An open circuit would be incomplete. So there's a gap in the wire, not everything's connected, maybe one battery's facing the wrong way. Closed circuit would have all those complete in an entire loop. And in the same way we had a light bulb, it could be a motor. And we could close the switch and then allows electricity to flow because the motor is the resistor. What allows electricity to flow? Well, some materials conduct electricity. Metals and solutions with ions in them, you'll see more about that in chemistry next year. Both of those conduct electricity. Insulators are materials that don't conduct electricity. So glass, paper, Teflon, rubber, wood. You'll notice that when we have a copper wire, we wrap it. So copper would be a metal. It's a conductor. We wrap it in an insulator like rubber so that we can hold that wire without it shocking us because we also conduct electricity. Let's talk about how we're going to draw a circuit diagram. So we're going to represent the battery with a vertical line and a smaller parallel vertical line. And we'll consider the larger line the positive terminal and the smaller line a negative terminal. You might see these stacked up like another set of a tall vertical line and a parallel small line to the right of it. That would just indicate 2 batteries like we did in our lab. You could draw this out with 2 batteries. You do the battery here and then another one to the right of it, another tall vertical line, another short vertical line to show that there's 2 batteries together to create that voltage difference. A switch will represent like this. This is a switch that's off, so an open circuit. If we want to close the circuit, this would just click down right into there, completing the circuit. A bulb will generally represent with that X, and then the wire just a straight line. And for a resistor, we'll use this squiggly line going up and down if it's a resistor other than a bulb. Okay, your multiple choice question, which of the circuits below would allow the light bulb to light? So which is a complete circuit, closed circuit? So take a look at each. Feel free to look back at the description of circuit diagrams. Different light bulbs drawn here with the squiggly lines. You can choose whichever one you like. Whichever one of those 2 drawings is fine with me for your light bulb. So which one of those, A, B, C, D, or E, would be the best answer? Go ahead and pause now. Feel free to go back through the video and then answer your multiple choice and then keep watching to get your free response. So recall our circuit from class today. We had a 3-volt battery. You can see the 3-volt battery here. We had a 30-ohm bulb. And then we need to complete the circuit with the amp meter. And we can see that there are 0.1 amps flowing. For voltage, remember we don't complete the circuit, we measure before and after because it's showing us the energy difference that the resistor uses. So we have 3 volts there and 0.1 amps. We wanted to see as resistance goes up, what happens to the overall current. So we'll keep the voltage the same of the battery. We're going to go in and turn up the resistance. We can see we upped the resistance and the current went down. Remember, resistance went up, current went down. That's an inverse relationship. Let's take a look at what happens when voltage goes up. So if I drop it back to 30 ohms, we had 0.1 amps for that before. Let's see what happens when I change the voltage of the battery to a 9 volt. Now I have 3 times the current. So as the voltage goes up, the current goes up. A direct relationship between current and between voltage and current. And the simulation just took a second to update, but 9 volts was the amount that it was reading there. So when we look at what that looks like as a formula, I stands for current, V stands for voltage. As the voltage goes up, it's in the numerator, that means the current goes up, a direct relationship. The resistance we found is resistance goes up, the current goes down, an inverse relationship. So resistance is in the denominator of our formula. And we call this Ohm's law. So I stands for current, it's measured in amperes or amps. Voltage is measured in volts, and resistance is measured in ohms, and we use this symbol for ohms. Okay, finally your free response question, how do resistance and voltage affect current? So think back on our lab today, think back on the video, complete your free response, make sure you describe each relationship on its own. So you could write 2 sentences about resistance and current, and then a sentence about voltage and current. And then make sure to submit, and you should get a copy of your responses in your SHC email.